kids. How are you today? Thanks for coming. I'm not looking at you because I'm trying to find my pen. Today is Unit 1. Unit 1, Day 6. Unit 1, Day 6 of Algebra 2 Common Core. Hopefully going to be Trig 2, but we're not there yet. So Algebra 2 Common Core, Unit 1, Day 6. What are we going to talk about today? I'd say we should talk about these things called piecewise functions. What? What in the world is a piecewise function? Sounds like something from the hippies. Well, in layman's terms, it's a function written as separate pieces. Separate pieces. Okay, so it's a function written as separate pieces. That's a piecewise function. Well, if you like what you saw today, just hit the subscribe button. Hopefully you learned a lot about all we talked about today with the piecewise functions, and hopefully you got a lot out of it. What? You don't understand? You mean to explain it more? Seriously? I just said it's pieces. It's a function written as like pieces. It's like a piece here and like a piece here. I'm thinking of a piece of apple pie right now that's sitting in my refrigerator. I'm thinking, that's going to be delicious. But right now, you want me to talk about piecewise function. I'm trying to get out of here and go have some apple pie and some coffee. By the way, my Brugger's coffee cup is empty because I'm waiting for my apple pie with my coffee. And now you want me to talk about piecewise functions. Okay then, we're going to talk about piecewise function. Only because you asked. Hit that subscribe button right now. Hit it. Hit it. Thank you. You probably didn't hit it, did you? You just faked it. All right, whatever. Let's talk. By the way, if you want a copy of these notes, go to Mr. Krause, K-R-A-U-S-E, mrkrausemath.com. Click on Classes and go on to Set 2 or Set 3 or Set 4. We're in Unit 1, Day 6. And here we go. So, the equation of this line is y equals x plus 3. The equation of this line is y equals x plus 2, but you'll notice they stopped. Something funky happened at -2. I'm only graphing this piece from -2 and going to the left, and this one I'm only going from -2 to the right, and in fact this one I'm not even graphing at -2 because it's an open circle. So this is a function. This is the function f of x. It's just written as two separate pieces, this piece and this piece. And it does something different at x equals -2. So at x equals -2, it changes from one function to another function. And so this is how we signify it. We still signify it with same function notation, but instead of written as just one function, it has to be separated into two different functions because they're doing two different things. So with this, here is the definition part of the function. But over here, I got to tell you what the domain for this will be, or what the domain for each piece will be. So this first piece only went from -infinity all the way up to, but not including -2. Well, another way to write that is x less than -2. So we're going to use this function, x plus 2, but only if x is less than -2. As soon as it turns out to be -2, as soon as x becomes -2, then we flip over to this function. So as long as x is greater than or equal to -2, we're going to use this function. Okay, thanks for coming. I hope you got a lot out of this video. Piecewise functions aren't... What? It's still complicated. Did I mention I have apple pie and Brugger's coffee waiting for me upstairs? Seriously? You want more help? I guess my pie is going to have to wait. It's probably now going to have to wait until after dinner because you guys are ruining my dinner. Oh yeah, I said it. God, kids are so rude. Completely irresponsible of my time. Oh, that's not the right word. All right, let's talk. How do we write a piecewise function then? Okay. Notice we have 3 pieces to this function. 1, 2, 3. Notice I've got a spot for 1 function, 2 functions, and 3 functions. Oh yeah, it gets difficult. So let's talk. If I drew this entire line in here, right here, starting in here, this would be the line y is equal to -2. But we're big boys and big girls now. We're not using y anymore, so this would be f of x is equal to -2. But we didn't draw it in forever. We only drew it in from here to here. So the first piece is f of x is equal to -2. That's that first function. And it's going from -4 less than or equal to x less than -2. Now I chose this to be less than -2. I could have said less than or equal to, but I'm going to put the equal to on the next piece. Just because that's the way I want to do it. And it's okay. Let's look at this piece. This is the line. It's got a y-intercept of the origin, so it's got y-intercept of 0, and it has a slope of 1. Well, you ought to recognize this as the function f of x equals just plain old x. So my second part of the function is f of x equals x, and we're going to do that from -2 less than or equal to x less than +2, because that ends up here at +2. Now again, I use the open circle there. We're going to use the closed circle on the next one. Now the equation of this line, let's see. The equation of this line is a little bit tricky. It's got a slope that's negative, so it's f of x equals negative, and it also has a slope that's down 2 over 1, so it's got a slope of -2x. Now I just got to figure out what its y-intercept is. Let's see. So it goes up to 4 and then goes up to 6. So plus 6. So the third piece, oh, and I should put a comma after these. The third piece is -2x plus 6 for all values from 2 equal to 2, but less than or equal to 4. 3 pieces to the function. 3 domains. All right, thanks for, whatever. Pi. I want pi. Lots of pi. More piecewise functions. All right, let's take a look at them. This is piece 1 and piece 2. Both of which have a y-intercept that's the origin. That's nice. This has a negative slope. This has a positive slope. So this one is, in this case, g of x, we'll call it g of x, is equal to negative, down 1, over 1. Oh, negative x, and then it doesn't even have a y-intercept. The y-intercept is the origin, so I don't need to put a number there. So the first piece is negative x. And we'll work on the domain later. This piece is up 1 over 2, and it's positive, so this would be g of x is equal to positive 1/2 x plus 0, but we don't need to put that. So my other piece of this thing is 1/2 x. Now, what's the domain for the first one? Oh, we're going from from -1 to 0, but I won't include 0. So from -1 less than or equal to x less than 0. And we'll include the 0 on the next one. So from 0 to 2. So 0 is less than or equal to x is less than or equal to 2. And there you go. That's that function. Oh, now we get to graph one of them. So if you plug in -3, you get 2. So -3, 2. If you plug in -1, you get 2. It was equal to, so those are both solid points. And I'll graph the line. Well, does that make sense? Negative 2. If I plug, isn't negative 2 in between these two? So if I plugged in negative 2, I would get 2. So this first part is just this horizontal line, the line y equals 2. Now we're going to do negative 2x. So I'm going to plug in negative 2 in here. What's negative 2? Excuse me, I'm going to plug in negative 1. What's negative 2 times negative 1? That's positive 2. So negative 1, positive 2. Oh, that's back here. I'll just do this piece in blue. So that piece is there, but that would be an open circle there, but that point's already filled in for this function, so we're good. Now let's plug in 1. 1. Negative 2 times 1 is negative 2. So 1 times negative 2 is negative 2. And that's a open circle because that's the way it was written. And I draw the line in between those two. Sorry about that. It's very difficult to draw lines in this graphics tablet. So now I'm going to plug in 1. Well, when I plug in 1 to that, since there's no place to really plug it in, it's just negative 2. So 1, negative 2. I'm going to get to fill this circle in. Now I'm going to plug in 2. Well, there's really no place to plug in 2. It's just going to be negative. It's just going to be negative 2. And I'll draw that line. Okay, there she goes. That's that one. Done with this. Let's try another one, because that was so much fun, and pi time's over anyway. So let's move. I didn't need any pi anyway. So we're going to plug in negative 4 into this equation. So that would be negative 4 plus 1. Well, hopefully you see that as positive 4 plus 1 is 5. So the point is negative 4, 5. Closed circle because it said equal to. Now I'm going to plug 0 in. So negative 0 plus 1. Well, you know that's 1. So plug in 0 and I get 1 out. And it's an open circle. Connect the dots. Okay, that's the first part. Now the second part, we're going to plug in 0 to this equation. So 4 times 0 minus 3. Well, that's just negative 3. So at 0, it's minus 3, and this would be a closed circle. Closed circle. Now we're going to plug in a 2. So 4 times 2 minus 3. That's 6 minus, that's 3. So at 2, we are at 3. And I will attempt to connect those dots. Okay, there's that function. Yeah, how about we look at that again? Somebody's probably saying, that guy is a complete and total moron. 4 times 2 is 8. 8 minus 3 is 5. So it should be 2, 5. Closed circle because it said equal to. Now let's try this again. That was a longer distance. Okay, there we go. That's the right line. There we go. That's it. That's the piecewise function. This is what happens when you have pi on the mind. Now, wait a second. I know this function. This function is the function f of x equals the absolute value of x. So are you telling me that I can rewrite an absolute value function as a piecewise function? Bro, that's awesome. Okay, it's not really. So if you thought it was awesome, it's not. It's not really cool. It's just weird. So let's take a look at these two lines. You guys can see this. Where the heck is my mouse pointer? Here we go. There we go. This part right here is the line y equals negative x. Because it's coming down. It has y-intercept of the origin, and it's got a -1 slope. This piece is y equals positive x for all x values, and it's got a y-intercept of the origin. So if we just take this line and stop it at 0, and take this line and start it at 0 and go to infinity, that's really just the absolute value function. So the first piece, this piece over here, 1, is equal to x so long as x is less than 0. And it's equal to, it's equal to negative x. Remember, the equation of this line is negative x. Let me erase that because it's a mess. It's just terrible. It looks like some juvenile did it. It's equal to negative x so long as x is negative or less than 0. Because think about it. If you plug in negative 5, negative 5 is positive 5. So it'd be positive 5. Or it's just equal to x so long as x is equal to 0 or greater than 0. And that's a piecewise function. Let's take a look at one. So where is the turnaround point? The turnaround point right now is 1. So before I would write this as f of x equals the absolute value. Wait, hold on. It's got a slope of 2. So 2 absolute value of x minus 1, because it moved to the right one, plus 5. But I don't want to write it like that. I want to write it as two pieces, 1 and 2. So let's take a look. F of x is equal to, now we're going to do this curly brackets because we're going to do it in two pieces. So the equation of this line is, it's got a slope of 2 and a y-intercept of negative 1.5. So it's equal to it's equal to 2x minus 1.5 so long as we are not going past this breaking point. So long as x is less than 1. So for every value where x is less than 1, we are doing, what am I doing? Oh my gosh, pi. I need pi because I am not thinking correctly, kids. Not at all. Let me go in black. Red and black, red and black, red and red. I don't know. Okay, so let's take a look at this line because I am doing something so stupid. This line has a slope. I was right. It's 2. But I was doing x-intercept instead of y-intercept. It has a y-intercept of 3. So its y-intercept is 3. So the equation of just this piece of the line is 2x plus 3. So 2x plus 3. But we only want to use that up until this breaking point of for x is less than 1. Not equal to, we'll just do less than for now. As soon as we get to 1, or for all the other values greater than or equal to 1, we want to use piece 2. Well, piece 2 has a slope of negative 2. I just don't know what its y-intercept is. It's going to be kind of tricky. Let's see here. So that's 5 and up 1, 2. So my y-intercept here is 7. So it's negative 2x plus 7. That's the equation of this piece. And we only want to use that one, though, for anything greater than 1. Now, let's make sure that makes sense. If I plug in 2, that's negative 4 plus 7 is 3. 2, 3. And there's 2, 3. Yeah, it worked. And if I plug in 3, that's negative 6 plus 7, which is 1. 3, 1. Perfect. Works out beautiful. All right, let's try it again. We're going to write these as piecewise functions. These ones aren't quite as tricky. We're going to do f of x equals. Now, from here to here, the equation of this line is y equals, it's got a slope of 1, it's positive, and it's got a y-intercept of 0, x plus 0, or we can just do f of x is equal to x so long as negative 1 is less than or equal to x less than or equal to 0. In this case, we're going to equal to, because see, notice that it's got a solid dot here. Now, at 0, so from 0 to, not equal to, so from 0, x less than or equal to 2. So notice it's an open circle. This is piece 2. That's just a horizontal line, and that horizontal line is 1. So no matter from 0 to 2, we're just going to plot the horizontal line f of x equals 1. All right, here we go. We got an absolute value. The cutoff here is negative 1. So if I'm thinking, let me call this g of x just to be fun. If I'm thinking about this, I'm going as long as x is less than negative 1, That's the first piece. On the second piece is x is greater than or equal to negative 1. So let me grab my red pen. So here's my cutoff at negative 1. We're going to use piece 1 over here and piece 2 over here. Let's see. Slope down 1 over 2. That's negative a half. Now the y-intercept is going to be kind of tricky here. Let me see if I can figure out this y-intercept. We're going down 1 over 2. So the y-intercept, it's going to cross right there, and that's negative 2.5. So it's negative 1/2 x, that's the slope with x, minus 2.5. But we're only going to use that as long as x is less than negative 1. Now we're going to use this line, which is up 1 over 2, so that's positive a half x plus, oops, no, it's not plus. What's my y-intercept on this case? It doesn't have a positive y-intercept. It has a negative intercept too, but it's negative 1.5 minus 1.5. And there's my two equations. All right, moving on. So let's analyze some piecewise functions just for fun. Is this a function? Yes, it is. Is it one-to-one? No, it is not. Fails HLT. And you could put up here passes, just to remind yourself, the vertical line test. I'm going to come down here and here. Is the inverse a function? No. It's not one-to-one. So it's not one-to-one. It does not pass. It is not. Its inverse is not a function. So domain. The left post part of my domain is negative 4, and the right post is positive 4. And it's equal to, so negative 4 to positive 4. The lowest y value is, or the minimum is negative 2, and the maximum is positive 2. So from negative 2 to positive 2. What are the x-intercepts? Negative 2, 0, and 4, 0. Right here. What are the y-intercepts? Well, there's only one. It's right there. 0, 2. Where is it increasing? Well, let me erase so I can see some things. It's increasing right here. So from parenthesis, because it's not increasing at negative 2. I don't know exactly what it's doing at negative 2. So at negative 2 all the way up to 0, it's increasing. Now from 0 to 2, it's neither increasing or decreasing. It's just flat. But it's decreasing from 2 all the way down to 4, parenthesis. Where is it negative? It's negative below the x-axis. So it's negative, bracket, from negative 4 all the way to negative 2, but not including negative 2, because at negative 2, that's when it's equal to 0. Remember that, okay? Where is it positive? It's positive from here all the way over to here. So from negative 2 to positive 2, it's above the x-axis, so it's positive, but you can't include those endpoints because those are zeros, negative 2 to positive 2. And where is it equal to 0? When x equals negative 2 and when x equals positive 2. And what is the minimum value of this graph? The minimum value of this graph is negative 2. All right. I thought I wanted you to tell me. I want you to tell me what this function is. So let's see if we can figure out what this function is. This is a funky one. It's going to have 3 pieces. So f of x is equal to piece 1, slope of 1, y-intercept of 2, x plus 2. Number 2, piece 2, it only is a horizontal line at 2, so it's equal to 2. And this one, slope of piece 3, slope of negative 1, and the y-intercept of 4. So negative x plus 4. Now I got to do domain. This one, bracket negative 4 less than x, less than or equal to x. Let's go less than negative 2. We're going to equal 2 from negative 2 less than or equal to x less than 2. Oh, by the way, this should be 4, not 2. Sorry. At x equals 4 is my other 0. Sorry about that. I'm glad I fixed that. And then it's equal to x, negative x plus 4, piece 3 from 2 less than or equal to x less than or equal to 4. And that's that one. The next one's going to have 4 pieces. Ooh. Is it a function? Yes. Passes the vertical. Let's do this in blue. Yes. Passes the VLT. Is it a one-to-one function? No. Fails HLT. And if it is not a one-to-one function, it is not, the inverse is not a function, not one-to-one. So no. Domain. Well, it goes forever and ever left to forever and ever right. The lowest y value is the x-axis, the lowest y value. These points right here, the lowest are the minimums. So it goes from bracket 0 all the way up to positive infinity. What are the x-intercepts? Negative 1, 0, and 1, 0. Those are the points where it crosses the x-axis. What is the y-intercept? That's the point 0, 2. All right, so where is it increasing? Well, it is increasing in this section, and it is increasing in this section, not including the endpoints. So from parenthesis negative 1, comma, 0, it's increasing, union 1 to positive infinity. It is decreasing in this area, decreasing here and decreasing here, and that would be from negative infinity up to negative 1, but not including negative 1. That's a turnaround point. It's called a turning point. Union 0 to 2. Remember, we're using x values, so from 0, from negative infinity up to negative 1, it's decreasing, and from 0 to 1, it's decreasing. Where is it negative? That's the empty set. No solution. It's never below the x-axis, so it's never going to be negative. Where is it positive? Now that's tricky. It's positive everywhere but at negative 1 and positive 1. So at x equals negative 1 and x equals positive 1, it's 0. Now 0 is not positive, so you can't say it's everywhere positive because this doesn't have an equal to. So I have to say from negative infinity to negative 1, but not including negative 1, or from negative 1 to 1, or from 1 to infinity. And there's other ways to write that, but that's what we're going to write it like right now. What's the maximum of this graph? Positive infinity. What's the minimum of this graph? 0. Remember, minimums and maximums, we're talking about y values. These are y values. All right, last thing I got to do is write the equation of this. It has 4 pieces. 1, 2, 3, 4. And I'm going to write their equations right here, and then we'll work with the domain. So this one here has a slope of negative 2. So y equals negative 2x minus. Now, if we went down 2 over 1, I would be at the y-axis. So that would be minus 2. This piece over here has a slope of positive 2x. And if you notice, we go backwards, it's going to have the same y-intercept as the other one, so minus 2. The equation of piece 2 is y equals 2x plus 2. And the equation of piece 3 is y equals negative 2x plus 2. Got that? So it's got 4 pieces. And its cutoffs are at 1, 0, and positive and negative 1, 1, 0, and positive 1. So let's do our 4 pieces. F of x is equal to 4 pieces. Negative 2x minus 2, so long as x is less than negative 1. We're going to equal 2x plus 2, so long as x is between negative 1, less than or equal to x, less than or equal, let's just do less than 0. Now, I can do this at 4 pieces, but 2 of the pieces are the same, but whatever. We'll just do it again. Negative 2x minus 2. Plus 2. Negative 2x plus 2. That's the equation of this piece, of piece 3. And we're going to use piece 3 from 0 less than or equal to x less than 1. And finally, piece 4, we're going to use positive 2x minus 2. And we're going to do that so long as x is greater than or equal to positive 1. Wow, 4 piecewise functions. Okay, I'm still not going to be able to get my pie because, quite honestly, I got to go out and finish mowing my lawn. But I hope you guys enjoyed this. I hope you understand a little about piecewise function. If you don't, there's some practice problems on the website. Rewind this, go back, take a look, see what's going on. Piecewise function. It's nothing more than taking one function or a weird-looking thing and breaking it down into its small pieces. If you like it, hit subscribe. If you don't like it, hit subscribe and smile. Maybe I taught you something I didn't. If you watch this whole video, I hope I taught you something. All right, kids. Been a great day. Rock out, kids. Peace out. Bye.